do 2 examples. Ooh, these calculators are better. Okay. Really. All these calculators on top of each other. What V shape is this off of? A rectangular prism. Also, rectangular prism. This is your rectangular prism. Okay. This has a height. Right there. Cool. This is that. If I move these slightly over to 0, also move this slightly over, and I hold this so they don't fall on me. Are we still at the same height? Yeah. Do we still have the same volume, probably? Yeah, because our base is the same and our height is the same. If I move these no matter which way they go, if I make it purely dramatic, it's still going to have the exact same volume. So a prism is slightly tilted, we're going to have the exact same value no matter what it is. The height is the same, about the whole bit. Cool, that's a fun thing. These are all yours. So if I took, this is 11.2, we should probably start with that. This is volumes of prisms and cylinders. So we just had about, let's call it a rectangular prism. This is what we had with the calculators. If I tilt this slightly, this is a rectangle, right? If I tilt it slightly, what shape is this now? A scrombus?
No, rhombus.
Okay, if this is a rectangle. If I tilt it, it's now a parallelogram. So now I have a parallelogram. Like so. I can draw this, maybe. Okay, it's a little rough. But you get it, if it could be drawn better. I could do this with a triangular prism, a square prism, any type of prism. Or if I did a cylinder, like so. So draw a cylinder. That's up and down. So, Vincent, this is kind of like all these blocks that we were using. This is now a cylinder. It's a very short cylinder. If I tilt this a little bit each time, about the same height as it was when I was standing up straight. So standing up straight, I'll tell you that 1.2. If I tilt these all over, now height over here, ooh, it's still 1.2. It is not changed. So the cylinder is also true. So if I tilt a cylinder over, like so, it's still going to have the same height. Except instead of our height going from the center down, this is our height, it's now coming down from over here, like so. This is now a height over here. So same thing over here, this is kind of now the height, instead of it just being this line. Do you know what we call these when it's tilted? Any idea? No? Okay. Oblique? prism slash cylinder. That's when it's slightly tilted over. They both have the same height. So my formula for a prism is volume equals base times height. So if the height is the same and my base stay the same, these volumes are going to also be the same. There's another idea that goes a little bit deeper into that. I don't see this being used a whole lot, but it's being used in your book. In our book, in algebra, in the algebra book. Geometry. I don't know what class it is anymore. Geometry class. Ashley, what principle are we about to talk about? What principle are we about to talk about? How do you say this word? Raylene, how do you say that? See, I was at Cavaliers. Lily, how would you say it? It's like Italian. Okay, let's just stick with Cavaliers. Principal? Yeah? Cousin, how would you say it? Okay, cool. So this states that if two 3D shapes have the same height, and they have the same cross-section area, then their volumes are equal. Let's scooch down a little bit. Yeah, go ahead. I could have different cross sections. They could be different shapes. So let's take a triangular prism for a second. Sketch a triangular prism. Like so. It right now has a height of h. Now let's say I take a cylinder and I also sketch it so it's the same height. Gian wants to know this principle as well because he's going to learn it later. I have a cylinder. Why does my cylinder look so much worse than my triangular prism? Boom. There we go. These both have the same height. We're going to say they both have the same height. So if they have the same height, and I do cross section, let's do it parallel to the base. Ashley, if I cut my triangular prism parallel to the base, what shape is the cross section? What is the base of the triangular prism right now? Base is down below. Triangle, right? So this is my base. If I cut it parallel, so about this way, what shape is that going to be? This is my base, right? I'm doing it parallel to my base. So kind of like that. Parallel to the base. Do you want to go back to GeoGebra? Yeah, okay. Let's go here. Boom. It's already up there. Triangle in the bottom. If I'm cutting it parallel to that base, what is my cross-section shape? Yeah. Still you. Still questioning you. A triangle. So we have a triangle down below. So our cross-section shape is a triangle. There, it's right there. So that's my cross-section. That's the one I'm talking about. So this is my base. Camille. Next shape is you. We have a cylinder. If I cut that parallel to the base, what shape do we have? Circle. If the area of these two bases in the cross section are equal, their volumes are equal. They could be different. That's totally fine. A circle and a triangle. We have to calculate their area to see if they're the same. Do we remember our area formulas? Yes, no, maybe so. Okay, let's start with triangle. What is the area of a triangle formula? Yeah, 1/2 base times height. What about a rectangle? What is the area formula of a rectangle? Yeah, so base times height. That's it. What about a circle for a cylinder? Do you remember the area formula? I think we all should remember the area formula for a circle. Carson, what's the area formula for a circle?
N divided by 260 times 2 pi.
That would be if I want like a certain area. What about the whole circle? That would be circumference.
Pi r squared.
Yep, pi r squared. Pi r squared. That is the area formula for a circle. You might see another shape that you guys all learned about a while ago. If these two are parallel, what shape did I just draw? Oh, it's really tiny. Let's go back. I have two sides up top. They are parallel. What shape is this, Raylene? Trapezoid. Yeah.
Except for the circle.
Circle.
That comes after the equals sign behind B.
This is just the circle area formula for A. So let's do this. I'll write circle. A equals pi r squared. Pi r squared. So R stands for, what does the R stand for? Yeah, radius. So pi times the radius squared. This one?
Is that a 5?
Pi. Pi, like 3.14. Lily, what's the trapezoid formula for area? You don't remember? Really? Yeah. Okay, I'll give it to you. It is A plus B over 2 of the height times the height. That is the area formula for a trapezoid. What is A and B? If I'm talking about a trapezoid. Of, like, if I was looking at these, Would it be 1, 2, 3, or 4? 2 and 4. Yep, because the height is already like this distance. That's the height. So these are the two up top. So it's kind of like length times width. These are all lengths. So this is A. This is B. And whatever our height is. Right there. Okay. Lovely. We call our area formulas. Does anyone have any questions about the area formulas? Or this principle in general? Cool. So we are taking these. This is area of a two-sided shape, but we're making it 3D. So now we're kicking it to volume. So scooch it down. We're doing volume. Prisms and cylinders. So we gotta sketch them again. I'm gonna start off my prism being a rectangular prism for now. I'm gonna make it short. Vincent, what's your favorite 3D shape so far? A cube? Okay, that's a prism. Raylene, what's your favorite 3D shape so far? Triangular prism? Okay. I can draw this pretty well, I feel like. Okay, volume of this guy. Base times height. What is the base in this problem right now? Is it 1, 2, 3, 4, 5, or the front face, which we'll call 6, but I feel like if I do it, it's going to be bad. 1 is my side here, 2 is my top, 4 is my side, 3 is the back, 5 is the bottom, and 6 is our front. What is the base of this shape right now? Number 5, down below. That is the base. How do I find the area of that base? What shape is it? Rectangle. How do I find the area of the rectangle? It's to anybody. Carson, how do I find it? Length times width. Yep. So for a rectangle prism, we have length times width times height, because that's what we have down here. So that's length times width, and this is our height. Now, let's say we had a triangular prism, like so. Our base changes to what? I should have drawn it the other way. Boom, boom, boom. Kind of like that. That was worse. Okay, what is my base in a triangular prism? A triangle. And what do we say was the area of a triangle down below? How do you do that? What's that formula? Yeah, so this is now 1/2 base times height times the height of the rectangle. So let's call it kind of like big H. So I drew this better. And I drew up, up, and up. We have base down below, and we have big H here. If I went down, we need a perpendicular base. Perpendicular, we need an altitude going down. So my triangle down below, our height of this We're going down from right there. That is my height. And that is my base of a triangle. I'm gonna draw better. What's up, Drew? Yes, 100%. This is height. Altitudes. Remember altitudes from back in chapter like 8? About right triangles and similarity. Remember when I made you do geometric means? Oh, Holly was teaching you geometric means. You guys didn't do the ugly geometric means. Altitude is from the vertex down, making a 90-degree angle. That is my height. Down below is my base. So that's this entire length right there. You're going to get more shapes. You're also going to get a trapezoid. You might get a square. You got to change the start formula. This is the start formula. That is the nice one. Okay. We'll do brain break before we go into... What is the base of a cylinder? So volume still equals base times height. What is our base shape? Circle. Boom. And it has a what? What did I just draw? A radius. Right there. What is the area of a circle? Yep. Pi r squared. So pi r squared times our height. That is our true volume formula. And guess what? It's not changing. Unlike the prisms, cylinders don't change because cylinder always has a base of a circle. And we're not doing ovals. So, or ellipse, whatever you want to call it. That is the formula we're always going to keep. Prisms are a little bit more annoying because we might change what the base is each time. Could be a trapezoid, could be a rectangle, could be a square, Lily could be asleep, or it could be a triangle. Is it really? Oh, you should have told me. Pi, yeah. Drew, you keep asking me that. This is pi. See, I do it squiggle, squiggle, straight. That's how I do it. No, it's not 55. It's a weird 55. Okay, that is a cylinder. It gets difficult. We're going to have word problems. Do you want to start with a word problem? We're not going to start with a word problem.
We do one.
Yeah, we're going to... You want to do board now? Okay. Let's do a board one, and then I'll give you what it is, but it's not going to be a word problem, the first one. Look at, I already got your names ready to go. 3 groups, ready? Good? Again? I don't know if that was again. I know, yeah. Again was a shake. Okay. Drew, rock, paper, scissors, shoot. If I win, we do it one more time. If you win, we do it 2 more times. Ready? Okay, ready? Rock, paper, scissors, shoot. You win. 2 more times. Why does it do 3 times? Okay, 1 more time. Those 2 groups, go. No. Okay. What was the last and final one? Sorry. Those 2 groups. Go find the boards. Lovely. Okay, I will give you a problem that's starting off as not a word problem. Not a word problem. Sort of. Draw a nice, gigantic, rectangular prism. Jody, you are with Lily and Carson. This is a 10 centimeter by 15 centimeter by 5 centimeter rectangular prism. I'm going to put a jar inside of this prism that fits exactly like snug in this box. So there's nothing above it, nothing below it. It's exactly inside of this box. Down below, down below. Ooh. We are putting a cylinder inside this box. The jar is that. What is going on behind me? Vincent, scooch. Away from me. Go over there. For 5 seconds. Thank you. 1 second. Okay. I want you to find the space left over if I put a jar inside of there. How much volume is left over if I put a jar in this box? And I'll show you right now the radius of this is 5 centimeters.
Oops.
You want the answers?
It can't be 5 centimeters. It is 2.5 centimeters. That's okay. Yeah. I want you to find the volume outside of this jar inside of this box.
That's 2.5?
Yeah, it's 2.5. I changed it.
This week?
Yes.
Can I retake my test later today?
Okay, great. The answer to this one was volume equals 553.7 centimeters cubed. Okay, looking at the sheet of paper we have in front of us, I'm just going to project it because, so maybe, can this thing go? These are the type of wood problems you are going to see in your future. Right there. So look at the first one. Rogue has a 20 feet cubed of firewood in a firewood rack that's in the shape of a rectangular prism. So now you have to draw a rectangular prism that is 2 feet deep. The height from the vertex is 4 feet, and the height, I said the same thing twice. Scratch that out. And the length of the rack is 6 feet long. Would all the wood fit in the rack? That's the question. We need to sketch a triangular prism, find the volume of that, and if it is greater than that amount of wood, then yes, it could fit all the wood. Should I give you this guy for homework? Okay. Okay.